Okay, then let us start. Let us first finish the, I think this is the third approach that we implement our linked list. And if you recall, this time we define our own listable interface. Okay, and the purpose of this is just to try to get you understand how the linked list in Java library is implemented, okay, so that we can get more insights into the library. And in this case, so this linked list is not the one like we previously discussed. This is doubly linked. Okay, doubly linked. Doubly linked is so two-way. So not like previously, it's one way, is it? So the one-way simple is from the front to end. So when you do the traversing, etc. And for doubly linked, then you can both from front to end. You can also go back from end to front, etc. And in order to do this, for the one-way your node, you only need the next field, etc., to connect with the next node. Okay, but in this case, because you need to connect both, you need to do both the forwarding and the backwarding. We need to support, so the node need to have two fields. Okay, one is to the next, and you also need to go back. If you want to go back, then you also need another field. Let it point to the previous one. Is it previous one? So this is, we call a previous field. So this time the node changed. Okay, so each node has three parts: the data parts, and its next part, and its previous part. So it also has an arrow point to the previous node. Okay, so keep this in mind. This is doubly linked. Okay, two-way. Okay. And then let's see. So the node itself, so be careful, there are three fields, okay? We add another one previous point to the previous node. And because of this, it's a constructor, then not just the node and next. So you also need to take care of the previous one, okay? So that's the node part, okay? Still, we define node as a static inner class. And because of the features, it needed to both way, two-way, so forwarding way and backwarding way, so that's why it's instance variable. In this case, we not just has first, we also have a one called tail. Okay, so in this case, then our linked list looks like this. So this is one way, is it? So suppose we have 100, 200, 300, 400, and 500, is it? So this is the previous one that we learned. But now we also need a previous field. the previous field. So here we also have the previous. So for this previous, then it's pointed to null. Is it? So in this case, we have the head node. We also need a tail node. So tail node pointed to the last. Head node pointed to the first. But be careful, okay? Head's previous is what? Is a null value. And tails next is a null value. Is it? So that's the features, how you identify the head node and the tail node. And we have another variable here. We add instant variable, we call it count, so that we can keep track of how many nodes we have in this linked list. Okay. So to build an empty one, you just add head, tail, to null value, and the count to 0. Okay. So that's pretty straightforward. And then next, let's take a look at the add. Okay, so here for this add operation, for this add, we are going to add some item, but we are going to add it at some specified index position, okay, in the list. So there are multiple scenarios we needed to think about it. So the first case is you add at beginning. Okay, add at beginning. So how do we add at beginning? So let's see. And here, each one we have both front and back, is it? Let's take a look at the case. Okay, so here is the head. We have 100, and we have 200, 300, 400, 500. So here is this case. And here, suppose we want to add 0 and 50. We want to add 50, then 50 definitely we are going to add at the beginning, etc. So how do we do that? Is we first need to create a new node. So this is our new node, 50, is it? So we set its next and its previous both to null, is it? And but we needed to, this node going to be the head node. So that's how you set head to this node. Is it head to this one? Okay, head to this one, and oh, here this should be the case. This is because here is a tail node. This should be the case when you just have how should we this is for the empty, okay, not just add at the beginning and for empty list. You see, for empty list, that's the only node you are going to add. Is it? So you set head and tail. So both head and tail will point to this node, and its previous and its next both are going to point to the to null. Is it? So that's this case. Okay, that's this case. Otherwise, so what is this case? This is an index greater than count, equal to the count. So that means you are going to add at back. Is it add at back? Add at the back, then suppose over here. Then we need to create a new node. Okay, suppose 550. Is it 550 with this 550 item? Is it? And this field is going to be responsible with previous. So this new node is previous is going to set to the tail node. Is it set to the tail node? So this part of connection we establish. Is it? And then we need to identify. So over here, is it what next we want to do is we want to also connect this node to this new node. Is it to this new node? So what over here we do is we just do the traversing. Is it traversing the cursor going to be at the tail node? Is it? And then its next is also going to point to this new node. Is it to this new node? And then you reset tail to this node. Is it? So then after that, you add this new node at the back. Okay, at the back. So that's this case. And then, so over here it's the case, just insert in the middle. Is that? Insert in the middle. Okay, when we do insert in the middle, then over here, suppose we want to insert some, suppose here is 200, here is 300, okay, and we want to insert 250, is it? So we first need to find the cursor, is it? The cursor. Okay, suppose this is the cursor that we found. Is it? We found. So then we create this new node. This new node, its previous, we set it to cursor. Is it? And its next, we set to cursors next. And then we set to cursor. But that's not just done yet, because the 300's previous also point to 200. That's not right, is it? You need to make this point to here, is it? So that's why the cursor's next, that's 300, and its previous, is it? Point to this new node. Okay, point to this new node. And also, is it this cursor's next shouldn't point to 300. It should also point to 250. Is it? So that's when you insert in the middle for the doubly linked. So you have multiple updates for the previous and the next. Okay, so we just need to be careful here. And then for the equals, it's pretty similar as the previous, okay, because you can just do the node by node checking, okay. And this is kind of like the indexing operation. So it's also pretty straightforward. You just find the cursor, then you get its data, okay. And the index of, then it's also similar, nothing new here, because also over here you can use for each loop. It's because this implementation already implemented the iterable interface. That's why you can do it, okay. And then for remove, we also need to be careful, okay. So there are multiple scenarios, is it? Of course, if your list itself is empty, you can not do anything, is it? Otherwise, if you want to remove the front node, is it? If you want to remove the first node, no matter what's next is, so this is a head node. And if you want to remove it, is it? So then the head needed to point to its next, is it? So head updated to its next. And because it's first, then if this, suppose you have another node, is it? And then this one is still pointed to the one you want to remove, is it? You shouldn't let this happen. So that's why you need to update its previous to null. Okay, so that's how you remove the front. And of course, you need to also update the number of nodes. Okay, so just be very careful. Okay, when we do the remove, you need to also update the front, not just update the head node. Okay, and the similar, if you want to remove in the middle, so this part is similar as a one-way. Okay, you just need to find where the location is. And for remove, you need to do the pair advancing. Okay, because you also need to remember who is the previous node. Is it? Then in this case, so this is the cursor, is it? And this is the previous cursor, is it? We want to remove this one, is it? If we want to remove this one, we already located it, is it? Then you need to get its next, reset to cursors next. Is it reset to cursors next? Okay, it says if previous next, now it's a null. So if this is null, it's not a node, then this should be set as tail node. Is it? So we need to take care of this kind of special cases. Is it? Okay, if previous is not a null, then it's this case. Is it? It's this case, you also need to update this link. Is it? This is what? This is cursor's next. Because the next previous, is it? Need to set to previous. Okay, so you also need to update this case. Okay, so we needed to be careful. There are multiple cases we need to take care. Okay, so that's remove, and you can also remove at specify index. Okay, so the concept is similar. Okay, and clear is just it's pretty simple. You just reset head and tail to null. Okay, for the size, you just return the number of counts, and two strings are similar as previous one. And over here, we also implement like that iterable, so iterator. Okay, and this iterator going to use this linked list iterator, and linked list iterator we define it here. Okay, and over here we just use the next part. Okay, so for this one, so this linked list we defined, it's a one-way. Okay, so from beginning to the one way is forwarding. Okay, forwarding. But because of, if you recall, this list supports both forwarding and backwarding, etc. So we want to do some bi-direction iterator, etc. So we can also define a list iterator, and the type is called list iterator. List iterator is two-way. Okay, both forwarding and backwarding. Okay, both ways. So let's see this direction linked list. Okay, so it says it implements that list iterator. The list iterator itself supports bi-direction. Okay, and because of this, then for this it's a little bit of complicated. Okay, so we have this inner class. It has multiple instance variable. Okay, it has a current one. You initialize to head to the first node. It also has another one called the last accessed. Okay, so this one used to remember where the iterator last term landed, is it? And it's initialized to no. Okay, and also have a index keeping track of. Okay. And the constructor, it has two constructors, the default one and for this one. So for this one, it's just to try to call to keep. So this one is just where you want it started. Is it? So some specific index. So start at the specified index in the list. It also allows us to do this. Okay, then basically we know it's quite straightforward. You just keep calling the next, is it, if it still has next. And how do we check if it has next? So based on the count. So that's why we use a count. So that helps a lot. Okay, so that we don't need to do another embedded loop. Okay, and it has previous. It's similar, just using index. Is it? And then in this case, we can also keep track of, because it's both ways. So you want to know the previous one and the next one. Is it? So both in this case, return index, because after that, you're going to call next. The next will update the index. Is it? Or the previous will decrement. Okay. So that's how we handle the previous index and the next index. So the next is similar as what we learned before, okay? Because in this case, the current, is it represent your current location, the current iterator, is it? So the next going to update it. So that's why you also need, before you update, you need to keep track of where the last access is. So that's how this part works. You keep track and you get to the current information. Then you update. The index also updated. Then you return the item. Okay. So this is regarding next. For the previous, it's similar. Is it? So the last access, you still need to keep track of the current, is it? And then for the current update, it's based on current's previous, okay, previous. So that, and then index is decrement, okay. But we also needed to be careful, okay. The scenario when like the list itself is already empty, is it? So some information like that. So all sorts of information. And for this iterator, it also allows the set operation. Okay, set just update the last accessed data information. Okay. And it also support, this time, it also supports the remove operation. Okay, so the concept is similar as what we discussed. You just need to be careful, okay? Whenever you do remove, not just get rid of, you also need to update the next and the previous field, okay? It also supports the add operation, okay? So it's similar as the add operation previous we discussed, but you just need to be careful about the last X and the current, how to update. Okay, so we are not going to go to detailed discussion. So anyway, so this is this generic linked list. Then we can go ahead to use it. So this time we create a linked list of cars using our doubly linked list, etc. Then we do the same thing, add a number of cars as what we previously did. Then we output the cars. Then we also want to check if it has certain car. And then we call the remove, okay? And this is on the car itself set method, okay? And once you update, we will also see the car also updated, okay? And we can also do the indexing operation, okay, indexing. And we can also do the find to see if certain car is in the list and where it is it? And over here, we use a for each loop. And what the next one try to show us, we explicitly also use the doubly. This is that a doubly linked list, okay. And then in this case, so you directly, we want to start from the very first one, to get to the very first one's iterator, etc. And then we just call the has next and next. So this time we call it external iterator. So we use iterator itself to do the loop, etc. And this is very nice because it can directly get you to the specified location, etc. And this time it shows us how do we do the reversing way, etc. Reversing traversing, okay, reversed way, okay, backward traversing, etc. Then you just use the previous and has previous, okay. And then what next one try to show us. So over here it's just to show if you use loop, is it? And at the same time, you want to do add or remove operation, is it? Then you can go ahead and use this list iterator. Okay, so in this case, this list iterator is just check next, is it? And then get to the item. Once you get to the item, you will say, okay, if it's a certain one, if it's a certain one, then you want to remove it. Okay, you want to remove it. So then this loop won't be broken. Okay, once you do this remove, okay, so it will keep doing. Okay, so it won't be broken. Okay, so that's regarding that remove. Okay. And then the same thing, you can also do add with the loop using list iterator, okay. So that's overall about this example, okay. We can also take a run of this example and take a look at the result. So let's see, so this is the very beginning, as if we add all of the cars, okay. And then we remove some car, etc. And also we update the first car, etc. And in this case, this is update the car itself. And it's also reflected on the list, etc. So the first car did update it. And also you do some search of the car, etc. And we use for each loop. And this is using iterator. You can see the result, it's the same, etc. And we can also do the backward. This is forwarding, this is backwarding. And then you can also see after you call remove, etc. So this is before remove. So after remove, we remove, we remove this one. Is it? After we remove this one, you can see it's keep going. Is it? So the loop is not broken. Okay, so similar thing, is it? So over here we add. Okay, we add some car. Okay, we add which one? We add this one. Is it after we add, the loop is keep going? Is it? It's not broken. Okay. So this is the neat part when you use the external, the iterator, okay, not the for each loop. Then you can directly do remove and add. It won't break your loop. Okay, so that's sometimes if you have a lot of adding and removing operation, then you can use you can do it using the external iterator like this. Okay, so that's this example. And then the last example. So in this case, if you recall, we previously said Java official library also has the linked list implemented. So we can also go ahead directly use it. Okay. So let's take a look. So over here, we repeat that as it. So this time we use Java libraries linked list. So we create a list of car. Okay, a list of car. And then we add the number of cars. Okay, the number of cars. And over here, we call the clone method. Okay, clone method. And here, be careful, okay. The linked list clone is a shallow copy. Okay, it's not a deeper copy, it says. So itself, okay. And then we can see, okay. So we can see, so over here, this is list car. The list car is the first one, the original. Then we remove this car. Is it? We remove this car. So after we remove this car, let's see if the second one, the clone one, going to be impacted. Okay. So let's see the running result. Okay, so this is the first one. Is it the first one? We have default 1, 2, 3, 4, 5. And this is the second one. This is the clone one. Okay. And here it's after we remove one. Is it? So let's see. So we remove. So that's the original. For the original one, that number 4 is removed. Is it? It's removed. It's not in the list. But the clone one, did you see? The clone one, it still has the car 4 in it. So it's not removed. Okay, it's not impacted. Okay, it's not impacted. So the linked list, from the library, okay, regarding the clone, is it? So what here, basically we can see the clone will have its own one, is it? Its own copy. Okay, so it won't be impacted by the original one. And this one, if you do something, it won't impact the original one. Okay, so in this regarding, it is a kind of like a deep copy. Is it a kind of a deep copy regarding the linked list itself? Okay, it has it on its own location. Okay, so that's regarding the linked list, like the remove method. Okay, and it also supports the get method, so similar. So this basically serves as indexing. Okay, the indexing, just like arrays indexing. Okay, and for Java's libraries linked list, it also supports iterator. And be careful, this iterator is a forwarding one. It doesn't support backwarding. Okay, you can only do one way. Okay, but it also supports you do the remove. Okay, we can also do the remove. And like previously we said, it's within the loop. Is it? The loop will not be messed up if you do remove. It will just remove the current one. It will keep going. Okay, a lot of time that's neat. And because of that iterable interface is support for each loop. So you can also go ahead and use it for each, but be careful, okay, using if you use for each loop, if you want to do the remove, the loop will be terminated. So this will be messed up. So you cannot do this, okay? So that's wrong. If you do want to do remove, then you need to explicitly using has next and next, not using the for each loop. Okay, so basically here is, so don't do add or remove inside for each loop. If you want to add or remove using external iterator. Okay, using external one. Okay, so that's the idea. And what next one try to show is in collection overall, it also support the stream method. Okay, the stream method is quite helpful because it can take care of sequence of elements, supporting the sequential and the parallel aggregation operation. So it's quite powerful, okay? So this is especially good for functional programming. So it's for the aggregation, so aggregate operation. So you can put multiple operations in one statement. Is it? And later on, because right now it doesn't show any advantage, but later on, when you learn parallel processing with Java, you will see this, when you do the streaming, and this can help you to do parallel processing. Okay, so you call the string, then you can do the for each. This is also for each loop. Is it? Within it, this is a lambda expression. So this lambda expression pretty straight, just want to do output one by one. Is it one by one? But you may say, oh, then what's the benefit? The next example shows. So over here is you try to find certain item in the list, but you may have multiple car file and it's a gray color. Is it? That's possible. You may not just have one, you may have multiple. And then after that, so this filter part, then will return you a sequence of car file. Then for each of it, for each of the car file, you have multiple, okay? Okay, you may have, okay, multiple car file. Then for each of it, then you can go ahead, do, what we can do is we also convert them to uppercase and output them. Okay, so you see, we aggregate the filtering and the for each loop together, that in one statement. And this is very concise way to code. Is it functional? We call it functional programming, because you don't care about, you just focus on, okay, what I'm going to do first, filtering, and next, for each of the filtering result, I'm going to output. You focus on those operation part. Okay, then you can use this way. Okay, and we can run it and take a look at the result. Okay, so we can clearly see that the result that it does work using the streaming, etc. Anything else? This is using iterator to do the loop. Okay. Okay, and then probably before we move on, let's see. Let me find that documentation Java 8 linked list. Okay, and then let's take a look at the library. Okay, so we now understand that Java linked list. So Java linked list is also provided by Java collection. Okay, Java collection. So it's a concrete generic class. Okay, so concrete generic class. Okay, it implements iterable interface we learned, collection interface, is it, and the queue interface also. That's why, if you recall previously when we discussed queue, when we create a queue, basically we use a linked list. And then let's take a quick look. Its operation part. So here's a list of the method. That the method, it has the add. So this add, just add to the back. You can also add to specify index. We can also do add all. That for add all, then this is a collection. So whenever you do plug in, you need to plug in some concrete class which implements the collection interface. Okay, that's how it works. And it also do add first and add last. This is for queue. And this add first basically is for DAC. Okay, for DAC. And if we go back here, if you recall the linked list, the implemented interface, it also includes DAC. So DAC you can also add first. Add at the beginning, is it add back, remove first, remove last, okay. So that's why over here to support both add first and add last, okay. And it also return a copy, that is at the shallow copy. But if your objects itself supports deep copy, then that's different, okay. And it also supports the search, so contains search. And the element is just using it to get, if you recall, to retrieve the front item, okay. And here get, it also can call get first and get last. So get last, this is for DAC. This is for queue. Okay, so that's why we say linked list in Java. Basically, it's you can also use it for DAC and for queue. And indexed all, is it? And the list iterator, is it? Okay, so this list iterator it returns list iterator. Okay, returns list. And it also support offer, is it? So offer is also add. Okay, offer first, offer last. You can insert at the beginning or at last. And the pick operation, is it? Get the first. You can also pick first or pick last. Okay, and the poll is remove. So you can also remove front and remove last. Is it? Also support pop. Is it? So pop then it's at the back. Is it? So in certain regarding it also kind of, you can also use it for stack. Is it? And the remove operation. Okay, so a number of remove. It can also update a certain item at you specify location. Okay, and it all can also convert to array. Okay, so that's all of this operation. And next, let's take a look at the list iterator. Okay, the list iterator. The list iterator says traverse. It allows us to traverse lists in either direction. Oh yeah, last class we already discussed this, is it? And also in the library, this list iterator, what it returns somewhere in the middle. It's the cursor position always like between the element. That will be returned by call to previous. Okay, so be careful. It's not landing on the item. It's in between. Okay, it's in between. Then you call it previous to get to the item. You call the previous to get to the item. And the element also call next, that you can also call next to get the next item. Okay. Okay, so that's the general information about linked list. Okay, so basically we complete our discussion about